So today I'll be talking about the growing need for space sustainability and satellite servicing's role in that. Um, so I like this picture a lot because it kind of shows the connectivity between the lunar surface and the Earth's surface and kind of what we need to be able to get there. And sustainable architecture is critical to that. So a little bit about Ada Space. We were founded in 2019 by former NASA engineers with over 130 plus years in combined aerospace cryogenic experience. Our mission is to develop the most efficient cryogenic systems for aerospace and hydrogen energy applications. We are currently funded for cryogenic propellant depots on Earth, in low Earth orbit, and on the moon. And we are strategically located on Florida's Space Coast so we can support the developing space economy there. On the right, you can see a couple of our concepts and projects that we've been working on: a terrestrial hydrogen liquefaction plant, an in-space propellant depot, and a lunar propellant liquefaction plant. Okay, so we are all about efficiency in cryogenics. First things first, we are Ada, not ETA space. So Ada is used in thermodynamics as a measure of efficiency, and we are all about efficient space and energy development. Cryogenic systems require maximum efficiency, especially liquid hydrogen systems, and cryogenic liquefaction, storage, and distribution systems will enable space sustainability ultimately. We have a saying that we like to say that's kind of sustainable equals reusable, which equals refuelable. So a little bit about satellite servicing and how it ties into space sustainability. There's multiple markets that are all kind of different, but they all kind of tie into the role of sustainability. And these markets are in-space manufacturing, space debris removal, orbital maneuvering and tows, docking and research stations, repair servicing, and most importantly, propellant servicing. So a little bit about orbital refueling. We're still in the early stages of the market development, but the ability to refuel a spacecraft with cryogenic propellants in orbit is a game-changing capability that will enable sustainable exploration systems. Cryogenic propellants allow higher delta V missions, direct orbital insertion, and higher mission masses. Bringing this capability to the market will provide propellant in orbit from the number of commercial startups looking to explore the resources of the solar system. So we've seen a recent shift in the past few years towards sustainable space development. And over here on the right, we've got a quote from our United States Office of Management and Budget, prioritizing some of our high necessities of sustainable space, including cryogenic fuel and storage and management and ISRU, along with in-space manufacturing and assembly. So our current state of the art in the market of orbital refueling, we've had some past missions such as the robotic refueling mission. We have some current small-scale resurfacing going on of small sats using hypergolics or xenon propellant, but this cannot really scale up. So it's a step in the right direction, but in order to have large mass infrastructure, we're going to have to use cryogenic propellants. So a recent shift in NASA's vision, they've been funding some tipping points for CFM demonstrations. And there's many different capabilities for orbital refueling, especially on the large scale cryo side. Upper stage refueling enables deep space and interplanetary missions. It drastically reduces launch costs per kilogram and enables reusable upper stages, which is good for sustainability. Orbital transfer vehicles have a number of different uses, but all needed to be refueled ultimately. So space tug OTVs with large masses, space debris removal, military applications, and in-space manufacturing. And then on the lunar side, lunar landers and large mass payloads, it just makes sense to refuel in orbit in order to get there cheaper. Lunar OTVs are enabled through this capability along with the permanent development of lunar infrastructure. So there's many challenges to orbital refueling, especially on the cryogenic side. There's a great cartoon that NASA developed a while back that kind of shows some of those challenges with storing and transferring cryogenic propellants in space. We hope to solve all these with our LOXSAT mission in 2024. but some of these include cryopropellant production, storage, and transfer, high efficient cryo coolers, thermal design and integration, rendezvous proximity operations and docking, cryogenic umbilical connections, low leak cryo valves, zero loss storage and transfer of cryopropellants, and hydrogen energy in the long run. So a little bit of overview about our orbital systems. We've got LOXSAT on the right, that's launching in 2024. And we've got CryoDock, which is currently funded up to the preliminary or critical design stage. And that will aim for launch in 2026 after LOXSAT is completed. So governments and private companies are engaged in a race to explore the solar system and utilize its limitless resources. But long-term success in this will depend on sustainable exploration architectures, such as the ability to refuel and reuse. Cryogenic propellants are the most critical supply need for large-scale infrastructure, and ultra-efficient production, storage, and transfer of cryopropellants are an enabling technology for many companies. We see an opportunity to create an early market for in-space refueling services and reusable spacecraft and bring this to fruition. So a little bit about LOXSAT. It was a 2020 NASA Tipping Point Award. It's a 140 kilogram cryogenic payload with about 50 kilograms of LOX in it. And the mission objective is to demonstrate the ability to efficiently store, control, pressurize, and transfer liquid oxygen in a LEO environment. Now, this has never been done before, and it will prove that cryogenics are indeed storable in space. So this launches in March of 2024 on a Rocket Lab Electron. We will be utilizing their Photon spacecraft for GNC power and communication. It's a 9-month mission in LEO, and we will be transferring LOX multiple times with zero loss storage and control from a 100-liter tank to a 10-liter tank. So this data will validate key design and analysis tools for liquid acquisition, pressure control, active and passive thermal control, propellant settling, slosh modeling, no vent chill down and fill. It will also demonstrate zero boil off, storage and transfer of cryogenic propellants, and propellant densification, optical mass gauging, along with some internal video on fluid visualization. So leveraging this data after LOXSAT, we'll be able to develop a commercial cryogenic propellant depot called CryoDock. Now, this will aim to be a standardized agnostic depot for multiple customers, what we were talking about a few slides back, the upper stages, the OTVs, the lunar missions. We've already completed conceptual design of a full-scale LOX-in methane depot for low Earth orbit, and we're working on our preliminary design for critical components of this structure. We also have multiple MOUs signed on the upper stage, OTV, and lunar lander side to work with us and collaborate to develop this architecture. So our launch is planned for 2026, barring everything goes well in the industry and we get the funding we need. So I'd like to show a little bit about our video on what CryoDock can enable for a sustainable architecture in space. Many things you see in this video will be very conceptual, but it's very, very good to see what it can do for the industry. So this aims to be the first commercial cryogenic propellant depot in orbit. So our first application is deep space missions and upper stage refueling. This is in the near term a critical need for many launch companies and can can reduce their ultimate launch cost for deep space missions, such as Mars. Our next application is reusable orbital transfer vehicles. In this demonstration, you'll see some space debris removal. However, this could be used for a plethora of applications. And as we all know, space debris is a growing concern for the entire space industry, and we need to eliminate single-use architecture. So here you see it getting rid of the space debris by deorbiting it, and then it would return to the cryodock to be refueled again. And our last application, debatably most importantly for the long-term sustainable exploration, is lunar transport missions. We need to be able to refuel in order to get there and back and establish a presence there, especially for large mass payloads. This will open the lunar economy and opportunities for a propellant factory on the lunar surface. Great. So, okay. So after cryodock is established and we have the refuel and reuse capability of being able to get to the lunar, to the moon and back, permanent lunar infrastructure can be developed. We have some current lunar funding from NASA in Space Florida and some other sources. Our first one is our Lunar Propellant Production Plant, which is a prototype for a hydrogen and oxygen production and liquefaction system for lunar surface ISRU. Now, this is going into the long-term sustainable infrastructure where satellite servicing starts with refueling in orbit, but then eventually moves to the lunar surface. We also have our Lunar Oxygen Station project. We have an international partner with Helios. They're a lunar mining company, and we're developing technologies for oxygen extraction, liquefaction, and storage on the lunar surface. We have also talked with some lunar lander companies about resurfacing in the future and some lunar safe havens. So we believe the future is hydrogen. The advantages of in-space propellant depots have been known since the beginning of the space program. The Augustine Commission recognized depots enable significant potential for in-space transportation systems beyond low Earth orbit. LOX and LH2 propellants offer the highest specific impulse of all chemical propellant combinations, and they are critical for high mass systems with high delta V requirements. It enables rapid deployment across multiple orbits with high energy maneuvers and is key for permanent space sustainability. You know, the water ice is already on the moon, on other planetary bodies, and it's already there for us to get, so we no longer have to launch it up once we are there and able to scavenge it. So hydrogen has not been baseline for smaller missions in the past due to perception of not being storable. However, Eta Space has demonstrated long duration, zero loss storage and transfer of LOX and hydrogen on Earth, and will demonstrate similar capability with LOX in orbit in 2024. After completion of the LOXSAT mission, oxygen can now be considered a storable propellant in space, and we will work towards cryodock and hydrogen storage. So to summarize, satellite servicing is key to sustainable development of space. Large-scale sustainable infrastructure requires cryogenic propellant storage and transfer. And development of sustainable orbital infrastructure in the short term will lead to infrastructure on Moon and Mars in the long term. And oxygen and hydrogen is the future of permanent sustainability in space. And back to our statement again, sustainable equals reusable, which equals refuelable. That's what we're all about. Thank you. Any questions?
Perfect. Wonderful, Bryce, again, for showcasing the need again for the refueling, for the space sustainability, and just generally in orbit servicing, very important for if we really want to, you know, turn the situation around with the space debris and what's really happening there, and just cleaning up the mess that we made and making sure that we don't add to it and don't lock ourselves into, you know, the lower Earth orbit and below that even. So definitely very important. So there's some questions here, and I have some questions, but also there's a question from the audience. So let's prioritize them first, and let's go with their questions first. So Juan Antonio is asking if there is any technological barrier to cryo, or is it just the need to get a more efficient design, get the certifications, and prove it?
So yes, there are not necessarily technological barriers, but it is not fully developed in the sense where it's not on TRL level 7 yet. It hasn't been flown in space. However, we have developed on Earth the capability for zero boil off storage and control of cryo. So we would like to say no, we just have to demonstrate and prove it in 2024.
Perfect, and good luck with that. So the next question is again coming from Juan. Once again, he's asking what is the lifetime again of the depot that you're developing before it cannot be used anymore?
So our first cryodock, realistically, it's going to be not a single use infrastructure, but we are going to launch propellant from Earth the first time. And when the tank's empty, I mean, it could virtually be stored up there for 1 to 2 years, and we would hope to sell the propellant by then. But we have developed technologies again to long-term store and control the fluid in space.
Wonderful, perfect. And the next question is from Mikhail. He's asking if you need to apply thrust during refueling operations in order to position fuel components within the tanks, and have you considered spinning the fueled vehicle pair instead? So that's a question.
So yes, we typically don't like the spinning fueling vehicle design, but we do have some liquid acquisition technologies that should be better in performance, really, on controlling the fluid.
Perfect. And how catastrophic could be a failure in the storage of LH2 LOX or propellant? So that's a question from Juan.
Worst case, I mean, it would just vent off into space, and we would not be able to store it. We would have, you know, vent systems and stuff, so it's not like it would blow up or anything. A lot of people are scared of the hydrogen in the sense where it's and oxygen in the sense where it's flammable, so it's a little more difficult to store or meticulous to store. But no, we don't see any problems there.
And do you believe this vented off again propellant could pose problems for some other spacecraft out there?
No, not necessarily. If anything, it opens opportunities for other spacecraft to come and refuel and then kind of like do missions such as deep space, debris removal. Yeah.
Perfect. Okay, thank you. So now a question from my side, and this is more of a less about ITA space, but more about your personal view and your standpoint again regarding the as a finance and business development expert in the space industry. What opportunities do you see for investors in the area of space sustainability and satellite servicing? So that's a question, because what we see so far, those projects have been mainly only backed by the government. grants and other programs. So when do you believe this will become viable financially on a scale that VCs and other private investors would be open to invest their money in it?
So from my personal viewpoint, we're ready now. Realistically, once we demonstrate next year the ability to store and transfer, we are ready to start beginning CryoDock. I know that's more of an AdaSpace standpoint, but on an industry standpoint as well, we hope to be the first to develop the market. So we're hoping it's within the next year or two, we're ready to see some investment on this side. And we have some mission and business models that show that CryoDock 1 could make a profit, a significant profit.
Perfect, wonderful. And what would be the potential use again of the depots and the again your spacecraft for the, let's say, lunar economy and lunar applications?
So we need to move away from single-use spacecraft, and imagine if a lunar lander was able to launch a little bit heavier in kilograms, but doesn't bring the propellant with them. The propellant's already in space, and they only need a certain amount of propellant to get there and back, but it's heavier to launch it from the ground. So ultimately, our depot would be able to provide them the amount of propellant they needed so that they could bring the extra mass. And as you know, every kilogram counts and is precious. And as I said on the panel yesterday, I've seen quotes for up to $1.4 million per kilogram to the lunar surface. This kind of capability could drastically reduce the cost of that. And back to the sense that cryogenics enable large-scale transportation, because some of the propellant servicing we're seeing right now is hypergolics and xenon, and it doesn't necessarily get us the large-scale mass we need to get to the lunar surface and develop it.
Absolutely, and I feel also that that would be very vital again for the upcoming lunar economy and especially for the infrastructure when we'll be again shipping the equipment and materials to the lunar surface, the ones that cannot be mined on the moon, at least those. So exactly, it helps also avoid this problem with because the more fuel you have to take, then the more mass that takes, and the more mass that takes, the more fuel you have to again add to launch again once again. So it's I believe it's really important what your team is working on. How do you think, Bryce, the space industry can balance the need for innovation and growth with the responsibility of ensuring sustainable practices? And I mean, mainly on the side of the satellite operators, especially the ones that are operating those large fleets, right, of satellites and the spacecraft. How do you feel now with the plans of adding tens of thousands of new satellites over the next decade into the orbit? Do you feel that is something that is ethical and sustainable, or do you feel that maybe they should take a deeper look within the reasons behind their projects?
Well, yeah, that's a very interesting question, and I do see some need for regulation on that in order to ensure sustainability. It's just a difficult question of what regulation. How do you stop countries and commercial companies from putting tens of thousands of satellites in space? Like, what is that
without again violating their rights, right, to produce new spacecraft?
Ethically say one country or one company can put more into space than another. So we're in a difficult situation there, but that is a very interesting concept to consider going forward in the future. And I think really ultimately that needs to come from the government side of things. Although we don't need more regulation from governments, typically it's something that might benefit the future. And hopefully our space debris removal operations will kind of help with that as well. Congestion in orbit, because that's
absolutely. And with this rates that we're talking again of the tens of thousands of new spacecraft and the current missions, as you've seen, right? So EtaSpace being one of the companies that are carrying the flag for sustainability, and with other projects out there such as Astroscale and other companies as well that are developing the space debris removal missions as well and monitoring. How do you feel, will those companies with their technologies, demonstration missions and future missions, do you believe they will be able to keep up with the rate of the new spacecraft being added and actually help prevent the Kessler syndrome?
Yeah, well, we've got to get started now, really, on that. But I'm not too sure on if it will. I hope it will. But there's a growing amount of satellites being put in orbit, and we're still working on some of our first space debris removal missions. So we've got to get moving real fast on that. And I think a lot of that funding and support is going to come immediately from the government side before the commercial side, before it becomes profitable, because removing space debris is not necessarily a profitable operation. So somebody's got to prioritize it and say, hey, we need to clean this stuff up.
Absolutely, yeah. And again, I was having a private discussion with one of the panelists that was there on the space debris panel on the day first. Vitaly Brown, he's from ESA. He's in charge again of the space debris monitoring and the projects and the regulations behind that. And he mentioned the Kessler syndrome has already begun, which was very alarming. Again,
Yeah,
even though it's in its initial phases, he mentioned it's already begun. So there was very alarming news that he gave.
That's about right, I would say. It almost has already begun. But yeah, we need to catch up with it, hopefully. We're having sustainability issues on Earth, so hopefully we can turn those around and as well continue or stop it before it happens in space, you know. It's kind of how I see that.
All right, and the last question probably from my side today here, Bryce. So with the rapid growth of the space industry, what do you think are the biggest challenges that companies like yours at the space is facing in achieving sustainable operations and practices? So that's a question.
Specifically for startups in the industry, I would say access to capital and awards and funding. We've been very lucky with awards and projects. We have great relations with NASA and Space Florida. But for us specifically, it's kind of like a chicken and egg scenario. And we've come into a lot of contact with these companies, and they're like, yes, we recognize the need for this capability, but it's not necessarily there yet. Or it's like they have to design their rocket to be refueled in order for CryoDock to launch, if you get what I'm saying. So we have to build it before they come, and we're still in the proving it stage. So we've run into some issues forming long-term strategic partnerships and getting them to commit 100%. Now, that being said, we've got plenty of MOUs for OTVs, upper stages, and lunar landers, but we're looking to get some a little more concrete and some backing and actually start working on CryoDock more than we are now, because we want to bring this to the market as soon as possible.
Perfect. And what would be the role of the, again, general audience and just generally the people, regardless if they're in the space industry or outside of the space industry, in getting those companies, if it's private companies or if it's governments? So if it's getting the private companies to take more sustainable measures and again focus more on the sustainable spend 10 point, and if it's for the governments to urge them to invest more in the market of space debris monitoring and removal and just the sustainability, how do you feel the role of the general audience and citizen science and space advocates would be in that regard?
Yeah, so we all play a role, and this goes back to the kind of sustainability on Earth. We haven't been too sustainable on Earth, so as a whole, we're moving into space exploration. We really need to. Everybody needs to be aware of this as a problem. And to be honest, I very well see it as a talked about thing in the general audience and industry. Almost, it's been space debris and sustainability has been talked about in almost every single panel or presentation. So to the general audience, just keep working on sustainable measures and make sure we're thinking about that.